Hi everyone. So this time we are going to discuss about the next tutorial. I hope you have already done the previous one. Let's discuss that. Okay. Yeah. So this tutorial is tutorial number 10, and we will discuss some of the methods that may be required for you. New methods, right? So let's take this question from here. Use mm, how to do that? Use 5-point midpoint formula to approximate f dash 2.0 with h is equal to 0.1 for fx is okay. This right here. Okay, the question is, I just write question in red. Use 5-point midpoint formula to approximate f dash 2.0 with h is equal to 0.1 or if x is equal to x is equal to. So what do you mean by 5-point midpoint formula? That you need to understand is that okay. So basically by 5-point midpoint formula, we understand that it should have values over this. It should have values over the grid points. Say if you start from say x naught, then you should have values from x naught plus h, x naught plus 2h, keeping x naught in the center, x naught minus h, x naught minus 2h, right? So how many values? These are 5 points, right? So total points are 5, keeping it's not in center, okay? Yeah, okay. So what we have to approximate f dash point to 0. So I basically write the formula here. The formula is, you can derive it clearly. F dash x naught is 1 by 12h fx naught minus 2h minus 8 fx naught minus h plus 8 x naught plus h 2h plus h to the power 4 by 30 and xi. Xi belongs to your okay. This is your formula for that. Yeah, and here you need to okay. So what is your f dash? So you have given your function and you have to calculate and x naught is 0.2, x naught is 2. Then you have to do f dash 2. You have to approximate f dash 2. So f dash 2 is basically and h's value of h is 0.1. So it is 1 by 12 into 0.1 into f of x naught minus 2h, f of 2 minus 0.2, it is 1.6 f of x naught minus h, which is, so I just write approximation instead of, I just neglect this, this character. F x naught minus h, this is 1.9, right? It is, so if it is 2 minus 0.2, then it is, sorry, it is 1.8, 1.9, and it is 8f 2.1 minus. Okay. So once you solve this, you can, I think, solve this. Once we solve this, then we get the required value. Okay, keep remember this formula. That is very important formula for understanding. Okay, this is one formula for this. Yeah. All right, now we go to another question. Consider the following table, then you have to use the second derivative midpoint formula to approximate f double dash 2 with h is equal to 0.1. So here also you have to use midpoint formula. Okay, so let me write the question. Okay, let me write the question first here. Question is, so question is this. So we are given the table. So given, just given tabular data, given the tabular data x fx, here x is 1.8, 1.9. I don't know what are the values, but anyway, whatever the values are, never mind. So this is your data you have. Just make it bigger. Yeah. Okay, this is your data. Then what you have to do is you have to use the second derivative midpoint formula to approximate with h is equal to 0.1. Like this earlier question we have done, similarly we have to use here some formula for that. Okay, so let me write that formula. Second derivative midpoint formula. So the second derivative midpoint formula, which consists of, you have to use all 5 points. Okay, let me see. Yeah, so if you have to use these 5 points, again, how many points? So we have x naught plus h, x naught plus 2h, x naught minus h, x naught minus 2h. Okay, so suppose this is your function. Okay, then I should write that formula. So the formula is f double dash x is approximated by minus f by 12h square. Okay. I just make it more smaller. Let be small. Okay. 12h square. Then the thing is, so what your work is to do, find truncation error. This case, find a truncation error in this case that you have to do. Yeah. Anyways, so what now? What is your, the thing is that now the f is coming from the table. So h is basically 0.1. So you know the values of f at this point, this point, this point, this point, this point. So all 5 values. Okay, let just take x naught, x naught, x naught, x naught. Let x naught is equal to your 2. Then you all know this. What is f x naught plus 2h, which is f at 2.2, f x naught plus h, which is f at 2.1, f x naught is equal to f at 2, x naught minus h is f 1.9, and these all values are given above in the table. You have to substitute these. This is your first equation. Desired result. Okay. Okay. So this is the thing. So this is about the first equation. Now we will discuss about another question. A student find the numerical value of f dash x at this. That's which of the following did the student use to conduct a differentiation if fx is e to the power x? We have to try every method. In that case, let me. Okay. I should write the question first here. Let me write. So numerical value, numerical so means f dash 3 is approximated by 20.22. Okay. Then which of the following is used to conduct a differentiation if fx is e to the power x? Then which method? gives approximation to be 20.22. Which method gives that approximation to be 20.22? Then we will discuss that. Yeah. So to understand this thing, we try to check every method. So first we use the backward difference approximation. Okay, so what in that? F dash x is approximated by, in that case, fx minus h upon h. Okay, in this case, in backward difference approximation. So fx is e to the power x at 3. So f dash 3 is approximated by f3 minus f2.9 divided by 0.1. Okay, and it is e to the power 3. So let's check which value is correct. The exponential function of 3 minus exponential function of 2.9. So exponential so e to the power 3 is, anyway, I just calculate the whole expression. Point, so 2.9. 2.9. Yeah. So it is 1.911, 19.11. So it will give 19.11. So which is not same as 20.22. Okay. So it's not right. Second, we use forward difference approximation. In a forward difference approximation, we use f dash x. Okay. Mhm. So what we do in that case, you have fx plus h, which is f3.1 minus f3 upon 0.1. X is 3, right? Yeah. H is 0.2. Sorry, h is 0.2, not 1. 0.1. 0.2. So it will be 10.11, which is, sorry, 9 point something, which is not same as, which is 0.2 actually. Okay, so what is f3.1? $2.112. It is basically 21.1241 divided by 2, which is basically 202 and how would it go? 10 point something. Not same as 22 point something, yeah. So it is not correct. So we only left with another approximation because in the options it is given central difference. So we only have to in this one. So what we have to do in this? So you know the formula for that. What is the formula for central difference approximation? Do you remember by heart? So it's basically so f dash s is approximated by fx plus h minus fx minus h on 2h. I don't think so. Why? Yeah, so h is 20.22 there. Yeah. So here it is basically f 3.1. Oh, sorry, f 3.2 minus f3 on. I was doing mistake there. 0.4 because h is 0.2. So you have to take 3.2 here. 3 point f3 minus. So we have to do again things. Yeah, need to do again these things. Okay, let's do that. So it's basically not 1, it's 2. 4.4469. Okay, so it's basically this one. This is basically 22.23. 22.23 is not same as 20 point something. So it's not a better. And what about this? Sorry. Yeah, so it's 3. So it's basically 3.36.408 divided by 2, which is 18.204. It is not same as 20 point something, right? So it's not correct. So this is fine. This is not correct. This is not correct. This seems to be correct. Let's see. We divided by 4. Okay. So I just write clearly 2.8. So what is F 3.2? It's 80.879 divided by 4, and it is 20.2, 20 point something like this, 20.22. So it's just it's a better approximation and which is same as close to this. Very so it's so I think a student got this answer from central difference approximation. So this is right. So central difference approximation is the student use. And you know, and this is a better approximation because of its order is higher. All right, now we go to another question in meantime. The velocity of the rocket is given as the function of time as allowed to use forward difference, backward difference, center difference. The best estimate for acceleration at t equal 1.5 second is. So it's the similar question kind of, but what you have to do here is I don't write this question to be clearly. Oh, what happened? Okay, so what you have to do here, just so acceleration, you know this. Okay, let me summarize this. I'm not giving this. Okay, so if the velocity is given in tabular data, then find acceleration. It's just simple, right? What you have to do. So treat velocity v as some function of t. Say it's vt. To find acceleration, we need to find v dash t. Say at t equals some 0.5. Say, I'm not sure this works, but this is the way you do. Like you already done with that. I'm not sure. I'm sure, but you have already done that, yeah, before. Sorry. Yeah. If we approximate, so we just do this question, and after that, we have rest 5 questions based on that. We will take a break for before that, but yeah, we just finished this. Okay, let me write this question. Okay. Question 5. So the formula for approximation dash x naught is even as f dash x naught is f x naught plus h. And bound for error is h squared by 6m, where I is bound for round of error and m is bound for third derivative. Mm, the bound for total error is. So we just need to use this. Maybe we can try this. Yeah, so what is fx naught plus h is doing? Fx naught plus h is basically written as fx naught plus and similarly fx naught minus h. So once you do subtraction over these two, then fx naught upon 2h will become, it will be 2h. It will be f dash x naught 2h. This will cancel out 2h cubed by, it should be f dash x naught plus h square by 6 f prime f triple prime x naught. So the bound for total error is, so what is the total error? Global error. So truncation error is basically or bound for, but global error, but total means total global. Global error is n times h squared by 6. So which is basically n h is basically some number k. So it is like length of it b minus a h. So total error, bound on total error is mh by 6, some cause. So mh by 6 is bound. So the statement is not correct. Yeah. So total means global error. I just explain you for a while. What does that mean? Is that there is a truncation error which you take on one time step, but global error means you just sum is from 0, 1, 2, 3. You just sum from say I equals 0 to 3. These truncation errors, error at I. So which is basically 3 times 3 minus 0 times the truncation error at I. Yeah. So that's what I done. Yeah. So we will have a short break for that. Uh, and we will discuss rest of the 5 questions soon. Okay. All right, I am back. Let's discuss the remaining stuff. Yeah, okay. Consider the following data, then use forward difference. Yeah, let me write this question now. Let's write that. So question number 6 is, consider so we have to use forward difference approximation to find out this. And this is easy, right? So what is in forward difference? You need x and x plus h, right? And h here is 0.1, okay? Clearly from the table. Then f dash 0.6 is approximated by, and x is 0.6. So it is 0.7 minus 0.6 divided by 0.1. So what is f.7? It is 0.6442 minus f.6, 0.5646 divided by 0.1. Then what you will get here? 0.796 will be the right answer. Okay. Anyways, this is easy stuff. Now next question. So next question is, I just write. We have remaining questions also, right? We'll try them. Okay. So question number 7 is, consider the data x, if x is 1.7, okay, and I just do this stuff. What is the 3-point forward difference approximation for f dash 1.3-point forward difference? Okay, let me write down the formula for that. So is it f dash or f double dash? F dash. So formula is, so if you have, say, points xi plus 1 and xi plus 2, and then formula is basically f dash xi is approximated by minus fxi plus 2 plus 4 fxi plus 1. Okay, and xi plus 2 is, so if x, so you have to start from 1.7, so xi is 1.7 and xi plus 1 is 1.7 plus 0.5 and 0.5. Okay, sorry, h into 1.7. Okay, sorry, it is 1 into 1, and h is basically your 0.5 here, so it is 2.2 and xi plus 2 is 2. Okay. So what you do, you have to just substitute these, substitute the values of f at xi, xi plus 1 and xi plus 2 in equation 1, and you get the desired answer, right? All right. Question number 8. Okay. See question number 8. Let me write it. Find A, B, C such that the approximation f dash 0 is approximated as AF0 as BF1 plus CF2 is exact for polynomials of degree less than or equal to. Okay. How do we do that? So for polynomials of degree less than equal to 2, you have like polynomials are, you know, so first is fx is equal to 1. So the technique is that for polynomials, you consider case 1. Since fx is 1, then f prime 0 is 0, implies, okay, I just use another pen. Use this equation 1, use equation star. Then you get 0 is a into 1 plus b into 1 plus c into 1. So a plus b plus c is 0. Okay. And next is consider case 2. So what you get? F time x is 1. So f prime 0 is 1. So it's like using again, use equation or we get a into f0, a into 0 plus b into 1 plus c into 2 is equal to 1. So b plus 2c is 1. Okay. Case 3, fx is squared. So you get f prime x is 2x. Then you get f prime 0 is 0. Equation is star gives a into 0 plus b into 2 plus c into 4 is equal to 0. So 2b plus 4c is So what you do is you try to solve these three equations, 1, 2, and 3, and find the values of find the values of A, B, and C. So if the question says you that if the question says you if in question it's written it's exact up to 3-degree polynomials, then you have to take 4 cases. If x equal 1, x square, and okay, yeah, and 4-degree, then 5 cases, and so on and so forth, like this. Okay, so once you got this, let me discuss the Simpson's 1/3 rule, and we have another question on trapezoidal rule. So, okay, what is Simpson's 1/3 rule and what is trapezoidal rule for integration? I think you have learned this here in class. So, Simpson's. Okay, let me discuss first trapezoidal rule because it comes first than this. Yeah, so suppose you are having this for me. Yeah, so we have this one here, and you have this one here, some graph like this, and you have starts from x0 and you end up with x1. Then you have to find this integral in this region. Then what you do is the value of function, say fx0 here and fx1 here. Then you take the average of, say, fx0 plus fx1 by 2. That will be your, the into del x, which is basically here del x is x1 minus x0. So which is basically the length of this rectangle, x1 minus x0 and this average. So this gives you the area in some sense. So the trapezoidal rule is based on this. So it says that the integration from say x0 to x1 fx dx is approximated by this way. Into del x. And like this, you increase because del x is, if you want to have here like this way. If you want at x2, x3, then you just sum up all these areas and you get this to any interval like xn, x0 to xn, where xn is b. and you have some step size, say h. H is del x basically, right? So it is can be written as del x by 2 in general, fx naught plus 2 fx1 plus fxn, right? Yeah, so this is done. So you have to use this formula here. I'm just going there. Where is that question? Use trapezoidal rule to approximate the integral with n is equal to 4. Okay. X cube. Yes. I'm not going to do calculations, but I'm going to explain the working of the method. Use trapezoidal. Use trapezoidal fx dx. I'm not writing that function specifically. With n is equal to 4, right? So n is 4. What does it mean? Is that if n is 4, then you need to consider points x0, x1, x2, x3, and x4. You need to consider 5 points, and you have to start because it starts from -2. You have to take -2, and it ends at 2. So you need to take x4 to be 2. Then how many points you will get in between? So 2. So it is h is or del x is basically x4 minus x0 by n, which is so n is 4 here. So x4 minus 2 plus 2 by 4, which is 1. Right. So h is 1 here. Wait a second. Yes, sorry for delay and was just trying to read. So H is del x. So you know these how many points are -2, -1, 0, 1, and 2. So this integral is approximated by if you use this formula here, then basically this from -2 to 2 fx dx is approximated by del x by 2. So del x is basically your h. H is 1 by 2 and fx naught plus 2 fx1. So what is fx naught? Fx naught plus 2 fx1 plus 2 fx2. So this is the formula which becomes like this, and you will get 1 by 2 f at minus 2, f at minus 1, f at 0, f at 1, f at 2. Okay, so you got that? Yeah, so this is that formula. So what I would suggest you look at the, in meantime, look at the truncation error for the above formula. Okay. Anyways, I'm not yeah. So now we will discuss another formula which is called Simpson's 1 by 3 rule. I hope you understand how to apply for a random function. Yeah. So what is Simpson's 1 by 3 rule? So I just write instead of this function takes, this rule takes 3. Sorry, this rule takes 3 values of the function. Okay, so what is these values here? So in the earlier case, you consider, okay, this is your function fx. Then you have these values, say x naught, x1, x2. The values I'm not showing here. So it tries to do some sort of filling using these 3 values. Like, so the filling is that it says integration x naught to x1, x naught to x2, because consider 3 points is approximated by delta x by 3 fx naught plus 4 fx1 plus fx2. Okay, it does like that. And delta x, you know, which is, yeah, you just write b minus a by n, which is h. Okay, so in general, if you have n points, so here, you know, n plus 1 points, it means that, so x naught, x1 up to xn, then you have to use like, you have to use x naught, x1, x2 in one way. You apply Simpson formula over there, you apply Simpson over formula over here, you apply Simpson formula over here, and so on. So you need n to be even for that. Simpson's 1 by 3 formula, you need n to be even. Okay. So what is the formula? Right. So if you are given the function value, so yes. So you can use this formula to do the similar type of analysis for the functions. And also there is one more formula. Why it is called 1 by 3? Because of this factor, 1 by 3 times del x, which is called Simpson's 3 by 8. Okay. Simpson's 3 by 8 formula, which is given as, so instead of 3 points, it takes into account 4 points, x0, x1, x2, x3, x4, x5, x6. Yeah, and so on. Here is also, yeah, it takes, sorry, x7. It takes, sorry, wait. Here it needs to be even. Here also you need n to be even, right? Yeah. Taking into account 1, 2, 3, 4, 5, 6, 7. Yeah, takes into account 4 values at a time, 4 values at a function. Basically x0 to x3 fx dx, approximated by 1, it's 3h by 8, x0 fx0 plus 3 fx1 plus 3 fx2. Okay, 1331 basically. So then you can similarly extend it for the other intervals. And so not even exactly, it's for odd also. So it's like 2n plus. I'm not sure. N is 1. Yeah. You just search for things. So again, study the truncation error in this case. So maybe we will discuss more questions on this in next tutorial. So I given some layout for that. Okay, all right. I just shared this PDF soon. Okay, all the best. And if you have any queries now, you can just ask me. I'm here. Yeah, so I'm stopping now. If this recorded video will be available soon, so don't worry about it. All right.